Welcome, and thanks for being all here. Today we're going to talk about reactive database access pattern. My name is Laurent Doguin. I'm Director of Developer Relations at Couchbase. We have a booth downstairs. Please come and see us at the booth if you want to learn more about Couchbase. We are a NoSQL database company. We do SQL and NoSQL like any NoSQL company these days. This is my social network. You can find me on GitHub or GitLab or Twitter, or La Marmotte Masquée, which is a brewery that I own. I brew beer in my spare time, which is called If You're in France. We don't export yet. Maybe one day. Reactive programming, why bother? Why does it even matter? Is anybody here already embracing reactive programming? Please raise your hand if you are doing reactive programming. There's not a lot of you, which is good. This is a very beginner talk, so hopefully people already know this, won't get bored. One of the reasons, well, some of the reason why we are going reactive in 2023 has sort of a gimmick, all talking about digital transformation, and now the internet changed everything, and now there's more and more users who generate more and more loads on your application, which means that you have more and more stuff to take care of, which also means that you need more and more hardware to manage all those users. And if you need more hardware, you automatically elevate the risk of failure. Failure is not a problem. Problem is not to know how to deal with failure. And so our goal as engineers in 2023 is to be able to manage all those new needs that came from, well, the internet and all those users. It used to fit into one machine. That was great. Now we need multiple machines, multiple servers to make sure that our websites or web application or other stuff are accessible by those millions, if not billions, of users, which is a great problem to have. And we've tried several solutions for that. We've tried to have more decoupled, event-driven architecture, which means that instead of having one monolith, you have messages that go through a message bus. If you may be old enough to remember Java Message Services, JMS, maybe some do, yes. Don't raise your hand. I'm old. Another kind of pattern like this, to instead of having one monolith, you had many machines to distribute that load and make sure that everything's decoupled, that when you need to change something or when something fails, you only replace that tiny bit. Now, the interesting thing about this is that the more you do that, more problems you have, because if you get more distributed, you get more machine, and you increase all the network calls between the services and all that stuff. So you basically create another whole set of problems that you didn't really want to have, but that you had to because, well, there was no other solution. So that's sort of why we went into a reactive architecture, not necessarily reactive programming, reactive architecture. In the 2000s, came the Reactive Manifesto, which was, I think, mostly came from the Scala world. And basically they said, if you want to be reactive, you need to have an architecture that is message-driven and that will allow you to be resilient. If smaller part of your architecture fails, it's better than if everything falls down. To be elastic, to react to user load. The more user you have, you want to be able to adapt to all those users that want to see your problem, and to be responsive, which means that you want to be able to react in case something happens, something goes wrong, or more users are coming to see your application. That's sort of, in a nutshell, the Reactive Manifesto. Now, if we talk just about reactive programming, not in terms of architecture, but in terms of programming, there's many definitions. This one is very simple. It's event-based programming, it's asynchronous, and it's non-blocking. What does that mean? Let's decouple everything. Event-based means when something happens, do something. If you do JavaScript and you have already implemented a function from an on-click, this is event-based. Be synchronous means let's start something now and stop caring about it. And once it's finished, at one point something is going to happen. If you did some JavaScript, you might have played with callback. You do a function and it's going to do something, but then there's only one programming. You program in imperative style, so you create a callback, you pass a function. That function will be executed once this is finished. This is asynchronous programming. And then non-blocking, which I would prefer to call non-waiting, because basically it's all about waiting for something to happen. Two concepts are very important here. Either you are I/O bound or either you are CPU bound. I/O bound means input-output bound, which means that you're waiting for something to happen based on input and output, and CPU bound means that you're waiting for your CPU to finish a task. So basically, your CPU if your CPU bound, if your CPU is not fast enough to finish the task in the time you want it, I mean, basically, the slower it is, the more you wait. And IO bound could be doing a network call and waiting for a network call to come back, waiting for an answer to come back. So you're just waiting for something to happen and not doing anything at the same time. If you go for a little schema, let's say you have a synchronous architecture and you want to read a file. What's going to happen is your thread is you're doing your stuff. You have file.read or whatever API you use, and because you are synchronous and blocking, while you are reading the file, you cannot do anything, and then you've read the file and everything's fine. If you're asynchronous and non-blocking, I want to read the file. There's a thread that's reading the file and doing some stuff, and once this is finished, then it goes back to the usual flow. Let me take you to the worst restaurant ever in the history of restaurants. Let's assume you have 100 table, and 100 table, 100 waiter, and 100 customer. If you have only 100 customer, it's great because every waiter will be able to go to a customer, sit them at the table, and then wait at the kitchen for everything to come out. And so you have a queue of people waiting for the kitchen to get the dishes to the table. And if you have some people that came in the meantime, well, sorry, the 100 table are occupied with the 100 waiters that are queuing on the CPU-bound kitchen. It might sound stupid, but this is exactly how threading model works if you used to maybe configure something like Tomcat, an application server. If you had 100 connection, incoming connection, you would have 100 thread declared to manage those 100 connection. And they couldn't do anything else. That doesn't sound super appealing if you map these to restaurants. It means that all the people that come in are just going to wait for other people to finish, and then you cannot even have several people at the same table. You only have one table, one waiter, and that's it. It sounds like a terrible idea. If you're going asynchronous, you have one waiter that takes people to their table, and then instead of waiting for something to happen, we'll go and take other people, and then the kitchen's going to ring and the dish is going to be ready, so the waiter is going to go and grab the dish and then serve it to the person that came in, which also allows you to sit several person at the same table. So it sounds better. That's pretty much the difference between synchronous blocking and asynchronous non-blocking applied to a restaurant. And you can see that it seems naturally like a better idea to do that. But is it really a better idea when you're coding? Do you have the same kind of problems? I don't know. If you tell me, I think we do. But it depends. And you're going to tell me, wait, I can already do some sort of asynchronous non-blocking thing. And I talked about JavaScript. It's right with JavaScript, you do event-based programming. You do callbacks, which is basically a way to do asynchronous coding. You have the future API that came, I think it was Java 6 or 7. And that was a terrible API. There was a method called get. And when you were calling get, you didn't really know if the thread had finished. But the moment you were calling get, you would become blocking and you would wait for the thread to finish its works and then give you the result. So you ended up being, it was supposed to be a non-blocking API, and at the moment you would do .get, it would block. It was really hard to use. It was really hard to compose stuff with this. So later came in compatible future and all those API. But at the beginning, I used to give this talk in 2014, so I feel really old. But at the beginning of futures, it was a terrible thing to do and to use. Callbacks, not sure if you're familiar with the notion of callback hell. If you type callback hell on Google, this is what you get. This is the unlimited indentation of function calling. So let's say you are doing something asynchronous, and when this thing is done, it's going to execute that function. And so you put the code of the function that also calls something asynchronous, which also calls something asynchronous, which also... And that's a terrible thing to read, and no one wants to read that. Now, this is an example of some code that is asynchronous, that is composable, but that is written with anonymous class. And really, who wants to write that code when you know that if you use reactive programming, the thing you see here, which is basically if something happens, then start something on another thread, and if there's an error, do this, and if there's no error, then do something else on another thread, etc., etc. Well, this does the exact same thing, but you're using reactive programming. So whatever the problem you have, if it's a poor restaurant problem or not, and that's the whole thing about this talk, and really the rest doesn't really matter. It's so much easier to read using reactive programming. This is a reactive programming library. It does the exact same thing than this. We'll go through most of this later during this talk. So yeah, if you have this, one thing that you need to remember, the only good reason to do that, in my opinion, outside of performance issues, is that it's so easier to read, really. I'm actually going to tell you what it does because I understand it better as well. You have a user service. You get all the favorite things from a user, which is a list of things. And from the list of things, you want you want many lists of other things. This is the favorite service that get details. Get details will get every detail of every favorited thing from the user. If it doesn't return anything, let's call the service that gives suggestion instead of favorites. If it does, let's take the 5 first, and let's send them on the UI thread. You have a thread that manages the UI, which you don't ever want to block because then the user will feel like this is non-responsive. If you're blocking something on a UI, it means that you cannot change anything that's displayed. So if you wouldn't have that, they would ask for the favorite thing, and you would have this waiter that would just keep turning and turning and turning on your website. And that's a terrible idea. No one wants to do that because it frustrates people, and frustrated people will leave to another website. So instead, you can start this in another thread, and once it's ready, you can send the result to the UI thread, and everything is great. This is so much easier. Anyway, non-blocking in computer science, I.O. bound. I told you about it earlier. It is about waiting for something to happen. Can be reading on disk. Can be a network call. And I talked about reactive architecture. If you want to be reactive, you know that the more microservices you have, the more they have to communicate with each other, which means that you are exposing yourself to a whole new category of problems. They might just not respond. You might have network issues. You might need all those things, and in any case, you have to wait for them to respond. If you apply that to the restaurants, the terrible restaurants, that would mean that your waiter would just be waiting for something to happen on and on each time you need to do an interaction. That's not great. So you want to avoid that. You want to do asynchronous programming to avoid waiting for something to happen. CPU bound, it doesn't happen that much anymore. It means that your CPU is not fast enough to easily move through the other steps of your program. And it used to be a thing, but unless you do, machine learning or very hardcore computation, it doesn't happen as much as it used to be because the hardware has catch up and is being significantly powerful. So it doesn't really happen anymore. The most common use case you have is being I/O bound because that's the world we live in. That's the architecture we build. You're waiting for a message to come on your event bus, your message for another service to answer. You're waiting for a click. If you're building UI, because it doesn't only apply to backend programming and database, it also applies when you're building UI. If you're building a UI, you're waiting for someone to click on the UI and do something when something happens. To keep up with what does reactive programming means, there are several reactive programming library, and there's one that I really like called Mutiny. Mutiny comes from the Quarkus Red Hat people, and basically they said that we are going to do a reactive programming library for normal humans. We're not going to talk about all the fancy terms that people use in functional programming. For us, reactive programming is a combination of functional programming, the observer pattern, and the iterable pattern, which sounds already too complicated, so they basically said it's just about programming with data streams. You have streams of things that comes out, and then you manipulate and do stuff with them. So that's one way of seeing this. Another way of seeing this is the reactive stream standard, JCR, whatever the name is in English. Reactive streams manifesto is a standard for asynchronous stream processing with non-blocking back pressure. You might, has anybody here has ever heard the word back pressure and felt like they were being gaslighted by people that know what they were talking about? And because it's a weird technical word, but it's actually pretty simple to explain. I'm going to do that in a minute. So it's asynchronous stream processing with non-blocking back pressure. what does back pressure mean? Back pressure comes from plumbing. I mean, it doesn't come from that, but that's a good analogy. You're doing plumbing, and you want to control the flow of waters or liquids or whatever. And so to ensure that your pipes at home don't break because there's too much water coming in, the stream is too big, it would destroy all your installation. Well, you can control, that's pipe number 2, you can control the way it works, so you can slow down the water that comes in. You can even reduce it. So basically you can control the thing that produces pressure on your system. Another way of saying this is this GIF that I like a lot. Coordinating flow control under stress condition. I'm going to talk a little bit more about back pressure later, but basically think about your website and something's wrong because there's too many users. You have the 100 waiter, you have the worst restaurant website. You already have 100 query that are managed by the 100 waiter, the 100 thread. And then you have users that are like, it doesn't work, and they're clicking on reload all the time, which builds even more pressure on your website. But you know nothing is going to happen because you only have 100 thread. You're doing blocking programming, synchronous programming, and all those 100 waiter thread are busy. And so more frustration, more pressure, more issues. Back pressure is describe this, and most reactive programming allow you to manage back pressure, to control the pressure, depending on who's producing the pressure. If it's the user, well, we cannot really do anything. If it's services that you control, well, you can tell them to stop hitting F5 all the time. You can also decide to don't care about whatever's coming, or you can decide to buffer as everything. We'll talk about it later. So in a nutshell, reactive programming is great for readability. That's my favorite argument. It's great to build resilience problem because you get reactive if something happens. We'll talk more about this later. It's great for performances because you don't have the worst restaurant story. You don't have waiters that are just being paid to wait and not do anything substantial. It's great for error management, for flow management. That's the back pressure story. We'll talk more about this a bit later. So I already talked about Mutiny, Reactive Stream. I think that's there's no logo for Reactive Stream. I think the first one is Reactor. It comes from the Spring project. I think the one on the bottom left is Reactor. Bottom right is React Aka, sorry. And does anybody know what that weird bird is? It's written there, it's a Lydon. Has anybody heard of Lydon before? I'm so disappointed. It is the Oracle way of doing reactive programming, which show you how has fallen Oracle. So I shouldn't say that on camera. Anyway, Couchbase uses reactive programming for our SDK. So actually we have by default a synchronous blocking API because many people prefer that. You can also get an asynchronous API. We used to use RxJava. We have moved to Reactive Stream because Reactive Stream was this attempt at having the same API everywhere for every implementation. So basically, we were all supposed to, support that API. There's been different thought about this API. Some people find it very difficult. Some people find it a little bit easy because they are great functional programmers and they understand everything. So the Mutiny aspect of it is let's call everything on something, do something, which is much more self-telling than flat map or fold or all those weird words that comes from functional programming. But we're going to talk about this today anyway. So yes, how do you get one single object? Use RxJava. You get a feature of an object or a completable feature of an object. How do you get multiple objects? Synchronously, you get an iterable, so a list, a collection, you know that stuff. In RxJava, it's an observable. It is a data stream, and so people are manipulating data stream. How do you get data or manage error or make sure that the data is here with a traditional API? Well, you can call next on an iterator, you can throw an exception, or you can return it once it's over. Because we are doing data streams and because we are asynchronous and event-driven, when something happens, we do something. So basically, is there a new object coming up in the stream? The onNext function is executed, and you can do your code. If there's an error, well, you get your function that manages the error. And if the stream is over, you would execute the uncompleted method. A stream can be over. A stream is not necessarily over. A stream is just a flow of things. Sometimes it stops, and sometimes it doesn't stop. Like you could have a service that emits data all the time, and so you would subscribe to that feed, and the moment you would subscribe to that feed, it will keep sending data, and it would never call the uncompleted method because there's no reason why it would do. And sometimes it's just a list of things, maybe a list of IDs, maybe the favorites of the user we saw earlier, and then you would use uncompleted, and you would be notified that the thing's over. Now, let's talk about database. This is a simple example. In Couchbase, we saw stuff in what we call a bucket. This is the asynchronous interface of the bucket because, as I told you, by default, we have a synchronous interface. We call the method get, which will give you an observable, and from that observable, you can subscribe. So something interesting to know is that until you actually call the subscribe method, nothing happens. You're just describing a stream of a document. You're just describing that method that's going to return something. The moment you call subscribe, it's going to execute the whole thing, and then you have whatever you want to do when you get the result. If you get the result, you print something. If there's an error, you print something as well. And if it's completed, then you say, hey, it's completed. Pretty easy. Now, let's talk about Couchbase and let's talk about marbles. Couchbase first. As I told you, we store things in what is called a bucket. And inside the bucket, you find lots of scope. Instead some scopes, you find collections. Basically, a collection is a table, a scope is a schema, and a bucket is a database. That's pretty much what it maps to in SQL. And of course, we have a cluster with lots of cool services. You can do SQL, you can do analytics, you can do search, everything in the same place. Good stuff, come to our booth, all that thing. Let's start with the basic. It's a key value store, so you can do all the CRUD operation. You can do insert, get, replace, remove, upsert, which is an update, and if it doesn't exist, insert the thing. And you could assume several things, and when you assume something wrong, you get an error. So basically, if you create something, but that something already exists, we assume the document doesn't exist, you will get a document already exists exception, and you will have to manage that. You will get a document doesn't exist exception if you do the get, and it doesn't exist, etc., etc. So this is just to give you some ideas of the thing we are going to use, which is exactly what I just said. Other error you can get, timeout exception because you have network issue, because network is hard, or other exception like maybe a back pressure exception, which basically is Couchbase sending a message to the Java SDK saying there's too much pressure, there's too much people trying to do stuff, come back later. Talk to the hand, come back later. That's that kind of thing. Anyway, marbles. Why marbles? There's a wonderful website called, I think it's Eric's Marbles. Eric's Java was sort of the OG, I am going way too slow. OG reactive programming database, library. So they were the first doing all the material to learn reactive programming. And so they started by doing marble diagrams, and those marble represent a stream of things. And in the middle, you have the operator, you have the function, the API that you can call to do something. So let's say you have an array of things. If you call observable.just the array of things, you end up having a stream of things. All right, which is what you see here. You can also do flow control, which is basically this is interval 1 is going to emit 0, 1, 2 every second. That's one way of doing this, or every 2 seconds if you want. You can create your own observable, and which means basically calling as much on next method as you want, and then maybe call on complete, maybe not. That's if you want to be very fancy. Usually those are either for very advanced use case, or this is what people are using under the hood to bring the other observable, like map. Has anybody heard about the word map before? Yeah, no one? Really? Yes, you have. Of course you have. It's the most simple of the scary operator, because because it comes from functional programming and it sort of make people scared for some reason. You get an object, you call map, and you're transforming into an object, another object. So you have a stream of things, and after calling the map function, you give it a function that transforms the things into another thing. So you, from a stream of things, you have a stream of other things. All right with everyone? Pretty simple. I have a document. It's a stream of documents. There's only one document. It's a bounded stream. So after that, it's going to be the uncomplete method that's going to be called. But anyway, and I don't want just the document, because in Couchbase you have the metadata and the actual content. So I want doc.content. So I want to transform my stream of document result into an actual JSON thing that I can use. Now, flat map is the most common and yet really understood one. You have a stream of things. When you call the flat map function, you give it another function that transforms a thing into a stream of thing. So from a stream of thing, you should have a stream of things. But no one wants to manage stream of things, because first of all, it's hard to say, and second of all, it's really hard to manage. So what a flat map does is, from a stream of things, transform one thing into several things and put them into the same stream. There's no order guaranteed, which is why you have one blue, one green, one blue, one green, and then two reds. This is how flat map works. It's extremely common in the world of database and reactive programming. Couchbase, and that's an history lesson because it doesn't exist anymore, it's going to be deprecated. So that's on me for not updating my talks. We used to be able to query things by creating MapReduce, by creating index with MapReduce function, which is what the view query was. Now we mostly use SQL, like every NoSQL database. So basically, you have a query. That query sends you rows, but you don't really want rows. You want the actual document. So you flat map from a stream of things to a stream of rows to a stream of documents, and then you can call the filter method, which we're going to see afterward, which basically give you only the document that have more than 5% of alcohol by volume, because one of our travel sample was the beer sample. If you come at the Couchbase booth at 6 p.m., we'll have beer. We'll also have soft drinks. So, feel free to come to our booth at 6 p.m. And then count them and then return the result. And all of this must only happen in 10 seconds. Now, think about this code and try to write this without a library like this, by managing the thread yourself, but by timing this has to be executed in 10 seconds, and if it doesn't work in 10 seconds, then abort. No one wants to do that kind of thing. You have a stream of things, you end up having a stream of things, but those are sorted. So basically, I'm going to get every document in the beer database, and we have some of type beer, and we have some of type brewery. So at the end, I'm going to have a stream of a couple of streams. It's going to be one stream with all the beer and one stream with all the brewery. Buffering is interesting. It allows you to manage flows, control back pressure. So instead of taking every single thing at a time, so let's say every customer for your restaurant at a time, and they all get one table, well, you can buffer them, and you can take 3 of them at a time and make tables, instead of just being overwhelmed by all these people trying to get in. That's one way of doing this. I am going way too slow. I apologize. This is a filter function, which basically only gives you the thing that you want from a stream of things. I only want the circle, so filter is a function that tests if the thing is a circle, and if it is a circle, then it ends up in a stream. First is interesting. You get the first, and you're only interested in the first result from the stream. Why would you do that in the database world? The way distributed database usually works is that you have one active version of the document, or several, and then you have several replicas. What could possibly go wrong? Several things. Let's say you have a split brain, like half of the cluster doesn't see the other half of the cluster, and so maybe the active version of the document is not available anymore, but you still want to respond something. In some cases, this is unacceptable. You want to be extremely consistent, and you want to make sure that you have the right results, and so you would throw an error, because you know that you are in a situation where you cannot guarantee a good result. in some situation, you don't really care. You just want the fastest result you want. So you can actually ask Couchbase to fetch the first replicas it finds, and that's it. And you just give the first one because all you want to do is give an answer fast to the user to not frustrate him or her, and then go on with your life. So that's what you can do with the first. Of course, you have last. Of course, you have stuff like this. Of course, last only works if you have a bounded stream that says uncompleted, because how would you know it's last otherwise? That's it for Eric's Java. Let's talk a little bit about Reactor. Reactor is the Spring reactive framework. It's used in Spring. It was introduced in Spring 5, also 5. Yeah, I think 5. It's pretty much the same thing that Eric's Java, really. So except that Eric's Java, if you remember correctly, the only data stream we had was the one on the bottom right. It was just an observable, which is the same as a flux. What they did in Reactor, and it's also true in Reactive Stream, is that they introduced a mono, which is a data stream that only contains one element. You saw that before. You don't have to see that, but this is without Reactor. This is with Reactor. It's so much better. I'm gonna fly through all of those because you've seen that already, and because I have only 20 minutes left. Let's find an interesting use case. Back pressure exception. So let's say that you have your service that talks to another service, and that throws way too much data at that service. What's going to happen in your stream is that you will get an error that says back pressure exception, and you will have to manage it. And so instead of doing this, what we're going to do here is there's 3 ways to manage back pressure. Really, there's dropping it. I don't care. People are asking stuff. It's fine. I'm just going to forget about it and answer when I can. That's one way of doing it. You can control the pressure. So we cannot control the user that type F5 all the time, but we can control our own services, which is what's happening here. And what's happening here is you only send a thing bufferize 100 things at a time, which is basically what you see here. You create your own observable or your own stream. On start, you request the first 100, and once those have been treated, you get another 100 and another 100 in order to not overthrow, in order to not put too much pressure on your system. There's several functions you can use for that. Sample, throttle, debounce. There's an operator for everything. We don't have to go through the whole API, but basically, sample is just like bufferizing things. Throttling is just like, I'm going to send you one, and then I'm going to wait, and I'm going to send you another, and I'm going to forget about everything that was in the middle. Lots of things you can do. This is the most interesting part, because it really, outside of the performance problem that you could have in managing reactive system, the readability argument is really important when you're trying to manage error and to react to error. And I think that's what is the most common in databases, especially in distributed system. Things will fail. There's no way around that. If you have a software vendor that tells you that their system is perfect and that there will never be any issue, you must run to something else. There will always be issue, and the people you trust are the people that say, if something goes wrong, we'll fix it, or we'll manage it, or we'll make do. But if someone tells you everything's fine, it's always going to work, no. I used to work in a cloud company. Trust me, things fail all the time. So in that sense, reactive programming or reactive architecture gives you everything that you need to manage failure. It's easy to fall back to another system. It's easy to implement retry if you get a document not find exception, for instance. A lot of cool things to do. So first thing, easy thing, managing error. It's not necessarily an error, but in order to have reactive system, in order to have things that are responsive, you cannot afford to wait an infinite amount of time. You need to provide messages, you need to provide answer to the other part of the service. If the other part of the service is a user, well, you will have a timeout, because if not, it's going to see they're going to see a waiter doing this all the time. It's going to be frustrating, etc., etc. So you need to put timeout, and it's pretty easy to do. Just call timeout on the stream and then subscribe to the stream. And once you've subscribed, something's going to happen. Before you subscribe, you've just described a stream that must be executed in 5 seconds. If not, you'll get a timeout exception. It's just going to get a document. This is a very simple use case. If we go back to more complicated use cases that we've seen before, again, how would you, you probably could, but that would be terrible, write the same thing without reactive programming API. So basically doing a query, getting all the results, that's pretty simple, and then filtering everything and counting everything and making sure that all of those different operations only happen in 10 seconds. This is way easier. Now, something I like to do is coordinated retry. Not sure if I have an example afterward. I still have some code to show you. Basically, you get a failure in the system, back pressure exception. You have to do something about it. You can just ignore it, because the more you ignore pressure building up, the bigger the accident is at the end. If you go back to the plumbing example, you probably get the image already. So immediately retrying when there's an error usually doesn't help. That's the user doing F5 all the time. We all know it's a terrible thing to do. So something you can do is, hold on, let's retry in a couple of seconds. Hold on, let's retry. If it doesn't work in 2 seconds, in 5, etc., etc., etc. So you can express different strategies to retry that would allow you to manage all the error. So if I go back to my example, or another example, I'm going to fetch a document beer. Let's say document beer is not available. I know it exists, but let's say it's not available because you have a network issue. If there's an error, I'm going to assume that it was a document not found exception, and I'm going to do get from replica. Fine, and I'm going to get the first one. Then I'm going to change it, and then make sure that everything happens in 2 seconds. If there's an error, I'm going to log the error, and if nothing is found, I'm going to return an error that says nothing is found. This is fairly simple. Now you can do, we've created, and I think it's in Reactor as well, but it's in Couchbase SDKs, a retry builder, which basically tells you have a stream. You're going to retry something when something happens. So if I get either a back pressure exception or a temporary failure exception, so you have to think about your usual class and your try catch, and then your catch with back pressure exception, and then your catch with temporary failure exception, and all those other things that were before. Here is just one method. If one of these happened, I'm going to create a delay, and I'm going to retry that every 5 seconds. Well, not every 5 seconds. The first time is going to be 5 seconds. If it still doesn't work in 5 seconds, this is a delay.exponential. So it's going to be 10 seconds. And if it still doesn't work in 10 seconds, I'm going to wait 15 seconds, etc., etc., etc. Do that 100 times. This is probably a terrible idea. I'm assuming the max will be much lower than that in real production use cases. But basically, you just described a retry strategy to manage the pressure on your cluster, wherever it comes from. You're just saying, if there's too much pressure somewhere, I'll wait, I'll retry. If it still doesn't work, I'll wait a little longer, and I'll retry a little longer, and retry. And that's pretty cool. Now, it's not the end. I want to show you real code. Not my email, real code. This is probably too small. Is that all right? No, probably not. Oops. It's probably a little better. I don't usually work on that code, but I think it's an interesting piece of code. This is the JDBC driver for Couchbase for data grip. So to information, Couchbase has a JDBC driver, so you can do proper SQL, and it's JDBC. And it's used integrated in data grip. Data grip is it comes from the JetBrains company, and it's a version of IntelliJ dedicated to browsing databases. And so they support Couchbase. And what I like about this code is that, well, it's a very real-life use case. The way it works is, if you want to query something using the JDBC driver, you need to create indexes in Couchbase. You have your primary indexes, which is basically just a list of IDs and a whole content of your document. So it's pretty much equivalent of a full scan in database, and then you can create more indexes. But when you don't have indexes, nothing works. So let's say that you have maybe an index not ready exception. What do? Well, that's what they did. They did an exponential backoff. Retry this. It was retry to create that index again, or to do that query again, only if you get an index not ready exception, and you retry every 50 milliseconds during 3 seconds. Well, that's nice. I didn't know you could do that actually. And instead of retrying 100 times, you just scope it to a whole duration, which is pretty cool. And that's it. And I cannot like this kind of retry real life strategy. Is there anything else interesting? Not really. I have 10 minutes for question. Has anybody any question? Yes, we have one question. Do you have a mic for the question, please?
I guess I have a question around testing. And I know that in the reactive model with the streams that often behind the scenes there's threads and you're kind of hopping around on different threads, but the point is that's intentionally hidden from you because the stream is the abstraction that you're working with. And testing, do you have a strategy for, do you ever run into situations where data is available in different threads and this causes trouble?
Testing sucks with asynchronous programming libraries. It's really hard to do. If you test non-reactive code, non-waiting code, you know exactly what happens. You can put breakpoints anywhere, and it will be super easy to follow because everything happens, one after the other. If you describe a stream of things and you want to break into one of these anonymous functions, then it's really hard because you don't really know when that happens. You don't really know where you are in the stream. It's hard. There are some so that's one of the reasons actually why some people move away from reactive programming because it's hard to test. There are some libraries that allow you to do that. You have some libraries that force order to be blocked, and if it's blocking again, then it's easier to debug. That's one of the solution. But really, if you must test in the right condition, what we did was provide a synchronous API. It's not the best thing to do. It's it's hard to test asynchronous programming, really. Do you have a solution?
No, I have not found a good solution.
No, there's no good solution. There probably is, but no, it's hard. There's a library called Blockhound, I think, that allows you to do something like this. There was a pretty cool framework called Ratpack, and in Ratpack, what you could do was transform any bit of code that was non-blocking into a blocking code, which would make things much easier because actually that's something I forgot to tell you, and that's a good point. In a whole architecture, if everything's asynchronous and reactive and non-blocking, that's great. But the moment you find something that is blocking and synchronous, that sort of defeats the purpose of being non-blocking for performance reasons, because then you'll end up having a new bottleneck. So if you want the benefits of the performances and the resiliency and everything has to be, or as much as possible, reactive. That's a lot of work. My personal opinion is that the most important bits and pieces of reactive programming is it's much easier to read and to compose than anything else. Any other question? Come on, we have 7 minutes left. We have a question over there.
Thank you. Have you found any good patterns to map asynchronous API into observables?
There's a lot of, not really. There's a lot of bridges between all the implementation I talked about. The reactive stream, you can go from a reactive stream easily to a Flux or an observable, or they all have interchangeable converter between each other. It really depends on, I guess, what you're the most used to use. I'm still somewhat I still prefer Eric's Java because that's what I've learned with, and that's and there's Eric's JS and there's Eric's .NET and there's like Eric's Java comes from the Microsoft. It was one of the first very successful reactive programming libraries, so that's what I'm used to use. So each time I can convert something to an observable, I do it. But some people prefer Flux, some people prefer completable feature and streams. They usually are bridges between each other. But my guess would be, you're in the team, everybody use the same thing and be done with it because it's already too hard to understand what every single operator does. If they change name, don't do it. That's one thing I don't like about Mutiny, and that's what makes it great. Mutiny, the Quarkus reactive programming library, all the naming are great because it's self-telling. It's very easy to understand what he does. It's not flat map. It's on something, do something. It's much more, easy to understand. But the thing is, it is so far away from all the other libraries and functional programming in general that if your team already have knowledge into reactive programming and into functional programming, they're gonna find it really weird and probably gonna dismiss it because it's not what functional people do. It's your choice, trade-off. I still love Mutiny. I think it's great to learn. I have no experience in the Lydon. Maybe some people do. Maybe not. Anything else? 5 minutes left. Yes. I can repeat the question.
Saying in terms of like the database, does the database have to support reactive programming for you to use it?
In terms of database, does the database have to support reactive programming to use it? Very good question. The back pressure exception I gave you, if you're using reactive programming and if you're expecting back pressure exception, then the error code that the database send you, it must send you something like this instead of just dying and not sending anything. So it goes back to the reactive architecture. Yes.
So also, if the database sends data in bulk. So if the database sending sort of data in bulk as well.
That's a good point because Postgres, there is asynchronous driver. There are several actually, but Postgres has always been made to just do the thing and send the whole thing. Whereas Couchbase has always been meant to send things as it finds them and then send them in the stream. So yes, there's difference of implementation between databases that will make them more suitable. It mostly falls down into the performance side of things. The reason they did the Postgres libraries, reactive programming Postgres libraries, is for the readability side of things, the compatibility, and all those I was going to say issues, all those good points about reactive programming.
But then you don't get the benefit. Sorry, you don't get the benefit of the speed increase or anything like that.
No, you don't. That's the problem about reactive architecture is that every bit of your reactive architecture has to be reactive. If something isn't and end up being blocking right in the middle, then you sort of lose the whole point of doing this. And it can happen pretty quickly because all the things that we use, are usually or have been usually blocking. If you are familiar with the file API in Java, there was Java.file, then NIO came in and NIO2, and NIO were the first non-blocking file reading API. So if you remember the first schema I showed you in the beginning, you have the API that read something, and if you are not using NIO, it would just wait. And something again, and NIO was allowing you to do asynchronous, to make an IO problem, so an IO bound problem, asynchronous so that it doesn't become a problem anymore. And so that's one example, but if you have a system with a lot of moving parts that do a lot of different things, you end up having this problem that is this API I'm calling, is it blocking? Do you even know if it's blocking? And sometimes, we use external services that are somewhat documented, and you don't really know if it's going to be blocking or not. So yeah, it's hard to make sure that everything is reactive. The good part is if it fails, you can put a timeout and you can be reactive about it being non-reactive, in a way. 2 minutes left, no questions? Yes, one question over there.
What do you think of Project Loom? Do you think that Project Loom is like a reactive programming killer because it makes the blocking code much less expensive?
It is a great question. Loom, you might have heard about Fiber, about Green Thread, about all those things. So basically, taking all the threading issues that you have one level down, and it's basically your language or the JVM or your runtime that's giving you a way to execute light thread. It's not a proper thread. It's basically, it's probably, I don't know how it's implemented, it's probably an event loop somewhere that's actually managing all those threads for you, which are not real threads. Those are light software threads. So it's an abstraction that remove the thread switching issue. I haven't talked about thread switching issue. It's interesting. The way a CPU core works is that when you do something, anything, you load a lot of data, information, and context into the first level of cache of your CPU. Each time you do something else with another thread, you have to remove all those things and put some new things into it. This is insanely expensive in terms of performance. So you want to avoid switching thread as much as possible. And what GreenThread, Fiber, Loom allow you to do is provide you an abstraction on this and make sure that it's not as costly as it would be if it was real thread. Is it gonna kill every reactive programming library? Honestly, I don't know. For me personally, it just depends on the API. I love the composability, the readability, the ability to express error management. I think is amazing, and so it probably end up going to be a mix of two. To be fair, it's probably going to be a mix of a nice API that you can compose and that's very readable, and that hide all those complicated things that you have to do and just allow you to code synchronously and blockingly, but actually no, it's a GreenThread or Fiber or Loom. Thank you so much for coming. This is the end of my talk. Thanks again. Come to the Couchbase booth. Thank you.